Hello. Okay, so I brought you something really cool. If you're working on something stylized, like a game or a movie you want to render or something that is stylized and you have an outdoor area. In the past couple of days, I've been working on this little scene here, as you can see. It's just a pond, just a single layer water. It's simple-ish. I think it looks really good. So as you can see, we have like foam here that is like moving around and forming and dissolving. Also, we have ripples. We have some real cool nodes with distance fields. So it's really interactive. And also, we have bubbles and some foliage on the bottom of the, like this whole area. And we have a process volume going on here. As you can see, it kind of has like this distortion or haze or something. So what I think that everything I've been working on here and everything I made here is a really great starting point for you to customize it and adjust it to your liking. And it saves you a couple of days, actually. So in this video, I'm going to show you how to create the single layer water node by node. And then I am going to upload the FBX models and all the texture maps I used to like a Google Drive or something somewhere. And you'll be able to download it and use them for free, obviously. If you don't want to use it, that's fine. I'm just gonna include it because I think it adds a little. So how many things we have? We have just one plane that we apply the single layer water material to. And then we have, so this is just one plane with the material on it. We have 1, 2, 3, 4 foliage style here. And also we have bubbles and the processing volume underneath the water surface. So it kind of feels like you're under the water. So first, we're going to go and check the single layer water material because that's the advanced stuff. It's not advanced. Sorry. It's just, that's the hard part. So let me just open the instance material here. If you follow my tutorial, you're gonna get something like this, where you can change pretty much everything in this scene, in this water. So, for example, the basic stuff, like the absorption amount. So how it works is that, it absorbs light, obviously, and you have to tell it what color should it absorb, and then you can just adjust the amount, how much it absorbs that specific color. So we have this murkiness stuff here that you can just adjust it. I think a pretty low number that you can is real nice that you can see the bottom of the pond here. We have emission strength here, which sounds strange, I know, but if you pay close attention here, we can see that, let me just lower this panel. So we can see that there is some like little dots here going on in the surface of the water. Let me just try to find a spot that it's, oh yeah, there. It's really visible. So some dots there. I think it's not necessary to have, to be honest. I just think it gives a little bit extra, a little detail there. And that's that is working with emission. So that's in the emission channel. You can increase the strength of it. So now it's more visible. I think a pretty low number was fine, I think. Also, we have a system where if it checks that is it night or day. So if I increase the strength of the emission, as you can see now, it's really visible. But if we were to set this to a nighttime scene, you can see that there's no emission going on there. So here you can see it just disappearing. So it's totally messed out by the lighting. So what's next? We have the foam, and we can set up a lot of things with the foam. So we can set up the contrast here. So the edges basically. We can set up the distance there from the nearest surface. For example, the shore here or the objects on the water. Also, we can set up the opacity here. Also, we can adjust the foam color here. So now the interesting part where we can set up the ripples here. So as you can see, the objects on the water have ripples around them. Also here, there are some ripples going on, which I think looks really nice. And it's really simple. And you can adjust these little settings here, like the ripple count. So how many ripples you have there. So what is ripple IOR? Basically how visible the ripples are. And it's not really, but it's kind of what it does. So it reflects light differently. And that's why we have this little illusion that there are actually waves on the water, but it's just the IOR change with an interactive mask. So there's no bumpiness here, as you can see. Whoops. So there's no bumpiness here, as you can see, just a flat surface. So it just how visible the ripples are here. That's what we use it for. So the next part is the size of the ripples and just the size of the ripples and the speed. Next up, the waves. Here we have a wave size control, which works like if you increase this number, then the bigger the waves become. So like this. And if you lower it, obviously it just lowers the size of the waves. And it's really simple again. That's it. Basically, that's it for the single layer water material. And now let's check the notes here. As I said, it's not complicated at all. It has like 4 or 5 major parts. And it's really simple, and I'm going to tell you how to do it exactly. So if you want to understand how this works and why it works this way, then I recommend you watch this whole thing. If not, then you can just pretty much copy everything I have here. And then later when you apply it to your water surface, the plane, then you just have to adjust the texture coordinates here, because obviously my plane size is bigger or smaller than your plane size. So you have to adjust that. So first, when you create a material that you want to use as a single layer water material, you have to change the shading model from default lit to single layer water. And then it will tell you that you need to have a single layer water material output as well. So basically the first thing you do after you change the shading model, that you just press tab and type single layer water material output here. And you just drag and drop it here. What this does is this is the absorption I showed you in the beginning. So how murky the water is. So basically how much light and what color of the light it absorbs and how much it absorbs it. This is the color we want to absorb here, which is like a warm color. So it's like a red, orange area color. Obviously, we don't want to absorb the whole wavelength. We just want to absorb like some part of it. So now, if we wanna, if you imagine, like this is the whole waveform, we absorb the reds, so we are left with more like bluish colors. So this is why the water seems pretty blue. If I were to change this to like blue, then you would see that the water would become like really brownish here, like a swamp or something. So if you want to use that kind of color, you basically just choose the opposite of the color you want the water to have here. So I want the water to be blue, so the opposite is like this warm orange color. So it's blue. And how much we want to absorb it is just a value. So you multiply these two together, and then you divide it by a really big number, like 40 in my case, because it has to be a really low number. And then you just plug it to the absorption here. What we have this scattering is this basically scatters the light around the surface here, which can look nice. So I didn't really play around with it, but I think you don't actually need this. You just need the absorption. Phase G, I have no idea what this does, and color scale behind water, it's kind of like caustics, but it's not really caustics, and it's not really projecting caustics well. So if you want to use this for caustics, then there's multiple much better ways to create caustics. So it's just, I think you don't need these three. You just need the absorption. And that's it for the single layer material. And that's it basically for this material. But you can just toss it there somewhere. Oh yeah, and obviously you want to promote this constant value to a parameter so you can control it in the instance of material. So what we're about to do is that we are going to disable everything I have here. I said disable everything we have here. All right. And we're going to start plugging in stuff. Like, oops. Like something to the roughness, like something to the opacity, something to refraction. And that's it. So opacity is here. It has to be 0. So it has to be full transparent, because the main effect you'll get is because of the absorption. So you want the plane to be see-through. So what we want to change first is the refraction, because the correct refraction for the water is that 1.33. So here, as you can see, this is the correct refraction amount. Just kind of strange, and I don't like it at all. And every single tutorial I watched, they say that it's just bad for stylized purposes. So what I want is that I want to use 1.033. So now you have something like this here. And I think it's much better. So now that we plugged something into the refraction, we can have normal maps here. And as I said, this is just, let me explain it real quick. This is just 2 texture samples. If you have the starter content enabled, then you can have these texture sample. So you just get this node, and then at the texture, you just scroll it down and type in water, and you will have water normals here. And I'm pretty sure I use this one. No, I use the other one. I use this one. So it's just, you get 2 of these. You plug a pender node to the UV for both of it, and you plug time to the time. So what this does is that over time it pans this texture. Now the texture coordinates you plug to the coordinates, and the reason why I have 2 of these is because I don't want these 2 textures to be the same size. So I set this as, I multiplied this texture by 6, and I multiplied this by 4. So it has different sizes. So the reason why I have 2 penners is that because I want one texture to go on the y-axis, which is here, and want the other texture to go on the x-axis. So it's being panned on the x, and the other one is being panned on the y. And now we're gonna just fuse those together with the blend angle corrected normals. The way I control the speed here is you could have like 2 constant numbers, like 2 constants like this. One is being the x and one is being the y. And you could just append these 2 and plug it into the speed. But I find it better as I have like a color value here, because it just, the green is the y channel, so the y axis, so I can just, when I pull up the instance material, I see that, all right, I want to change the y axis normal speed, so I change the green one, because the green is the y and the x is the red. So you can just, it's just for me, you can just change it actually. So now if we were to plug this here, so now you can see that it's working, and as you can see, one normal texture is going on the y-axis and the other one is going on the x-axis, so they are just crossing each other, which gives you this real great illusion that it has some waves. Obviously we want to control this, so we connect a full blue, so one on the B, the blue channel, and 0 on the other two. We want to just use this, we want to just lerp these two together, because the full blue is the flat surface. We basically have just a blend between these two. Blue is being the full flat surface, and the other one obviously is being the waves here. So this is how you control this normal. It's pretty basic. So now that we have some waves going on, let's create the ripples, because it's just really, really, really boring without them. So this is the whole node tree for the ripples. The reason why I show you this on a different object with a different material is because the ripples are basically just a mask. So it's better, you'll understand it better if I show you on a flat surface, on a flat new object with just a black and white mask going on there. So you can see how it works. So here, what we wanted to use is this distant to nearest surface node. And in order to use this, you have to select your object, and in the details, you search for effect. And then under lighting, you disable the effect distance field lighting here. It emits a distance field itself. So it's going to, you just can't use the node that way. So you have to disable this. So let me show you what this does. So you plug it in, you apply it, and as you can see, everything becomes white, but you can see some things going on here near every single object that touches this surface. So now what you want to do is that you want to divide this, because it's obviously too large at this point. And after you did that, you can see that you can now better see the effect. So it has a mask. It's pretty much full interactive, as you can see. So it's full real time, which is real nice, because if something moves on the surface of the water, then you can have ripples around it, which is real nice. You want to divide this by a big number. I used 40, but I think I used 120 in the final result. But now for this, let's just use 40. It doesn't matter. You can just experience with this. So you just have a constant parameter, and you just have a constant that you promote your parameter here. So you can change it in the material instance. And you just call it ripple size, because it's basically the ripple size. Now, what we want to do is that, I'm going to be honest, I don't understand why, but you have to saturate it based on the tutorials I watched on this. So you saturate it. And after that, we want to just reverse this with a 1-. Okay, so the question is, how do we make this move? And the answer is that with this sine node, if you get a sine node, what it will do, it's basically a graph that goes from -1 to +1, and then it goes back to -1, then it goes up to 1 again. So if I change the period here to 3, then what you will see that it's going to have a -1 to 1 to -1 to 1 to -1 to 1. And now, so we will have 3 ripples here. Oh, sorry, 0.3. Just like that. So now, we want to animate this. We want to make this move. So we add, I'm just gonna reset this to 1. And we are going to add the time to this whole thing. as you can see now, it's moving. It has some problems, but it's moving for sure. And then now we want to get rid of this flashing thing in the middle, which we can do with a simple multiply node. So we want to multiply this result with the mask itself and now plug it in here. So you connect the sign to the B and connect the 1 minus to the A. And with this, there's no flashing at all right now. Okay, cool. How do we control the time? You might ask. You divide it. So you want to make the ripples slower, so you divide the time. Although I used a multiply here, because with the divide you have to think about how much you want the time to be divided. So if you type 2, then it's going to be 2 times slower. Although if you multiply it, I think it's better this way, because if you multiply time by a number that is, that the value here must be minimum 0 and maximum 1. So you divide the time by 0.5, then it's going to be 2 times slower. It's just, you can divide it. You can just use a divide node, but you then have to use higher numbers. I just don't like that. So basically what I did is that I create a parameter here where I have a slider where the minimum is 0 and the maximum is 1. So if the slider is all the way to the right, then it's real time. Oops, I'm sorry, like that. And if the slider is all the way to the left, then it's like freeze. So as I increase this slowly, the ripples will become faster and faster, like that. How do you have more ripples? Like multiple ripples in just one now. You can use the period here, as I showed you earlier, but you can't really control it in a material instance. So instead of this, what you want to do is that you leave this on the default settings of this one, and then you multiply everything between the sign, everything before the sign node with a number. And this number will be the ripple count. So how many ripples you want? 2 ripples, 3 ripples, 15. Promote this to a parameter again, and then you say something like ripple count. Now what we want to do is that we want to have different numbers to the refraction here on the black and on the white. So we want to have the black as the default water refraction, which I told you earlier I use 1.033, and I want to use a different refraction for the white. So now the way we do that is that we use this as a mask. So we get a lerp node, and we get 2 constant values. One is the water IOR, and one is the ripple. So one is the black and one is the white. So we plug it in like this, and we just plug it into the refraction, which we don't have right now, but you just plug it in there. So instead, I'm just gonna put it to the base color. It's not gonna do anything. So I have the water IOR on 1.033, and I have the ripple IOR on like 1.055. Doesn't really matter. It will basically affect how visible the ripples are. So the closer you have this number to this number, the less visible the ripples become. So this is basically it. So you have this, what we created, and you just plug it in to the refraction here. So now with this, as you can see, we have ripples. Let's see how I made the foam. And it's really pretty simple again. How this works is that now, as you can see, the opacity is 0. So the surface is see-through. If I change the opacity and change it to 1, then as you can see, the water is not see-through at all. So there's no refraction going on. There's nothing going on because it's opaque at this point. So now if you put a color to the base color while the opacity is 1, so it's opaque, then you can see that everything becomes the color here. So you can just tint it this way. And this is really, really helpful for us because now what we can do is we can apply a texture, a foam texture here that I created real quick with some noise. If I have the opacity on 1, then it becomes opaque. And if I plug a foam texture to the base color, so then everything here has this foam texture here. The basic idea behind this is that you want parts of the water to be opaque, so it has the foam texture, and other parts to have like a 0 opacity, so it's full see-through. Okay, so this is the mask I have for the foam, as you can see. So we have foam where it's white, and as you can see, the foam is like forming and dissolving and moving and stuff. So it's not just foam in the water and it's there. It's moving. Also, we have foam where something is on the water there, like that. So the way we do this, we want to pay attention to this part here. So the reason being is that you have a cloud texture here, which is, again, if you have the starter content, you just type in texture sample, and under the material, you just choose the noise. You type in noise, and then you have this T noise, which is literally just a cloud texture. And I use this, as you can see. I have one here with the basic texture coordinates, so 1. And I have another one that has 5 on the tiling, so it's multiplied by 5. And I have 2 panners. One is on the x-axis and one is on the y-axis. And these two, I multiplied these two. So on this, every white part will be deleted. So it's basically going to have the effect that the foam is moving, because this is the foam and this is moving on the x-axis. And it's dissolving and forming because it's going to cross the other material, and where it's black, it's going to disable the bottom material. So just like that. So as you can see, it's moving and dissolving in the same time. This could be something that you just want to throw it on your water and call it a day. But I think it would be nice to have foam next to the surfaces as well. So, for example, around this leaf or this water lily here. And the way we do that is that we obviously have a distance to nearest surface again, which we divide by a number, like the last time, and we saturate it and we invert the mask. This is the same as the last time. But instead of adding time to it and using a sine node to have those ripples, we're going to... This is a black and white mask now. So this is a black and white mask here. And we want to break this surface up. We want to break this mask up. So we don't want the foam to be everywhere here. We want to be in this area, but in just little spots. So what we do is that we create another noise texture with the same cloud, T-cloud or something like that material, and we pen it again over time. We tile it, and then we use the cheap contrast again, which is going to have... So it's the same that we did here. So what this does is that it has, again, foam. We multiply this by the mask, like this. So now we only have those spots where it's near the surface. So like that. And now we have to fuse these two together. So the way you do that is that you just basically have these two here underneath each other like that. And then you just, add them together with an add node. And now if you plug this in, then you have foam near the surface that is moving and dissolving and stuff. So like there, and again there. And also you have foam on the water in spots in some places. So now we want to have a control to disable this and lower the opacity if we want to. So now, as you can see, white being where the foam is fully visible and black being where the foam is fully transparent. So now we obviously want to have a mask that controls, so just a number that controls the blend between a full black parameter and this texture here. So now what you can do with this is that obviously we want to use this as a mask. So let me get back to the single layer water material here. And now, as you can see, everything is opaque. So it's not transparent at all. And we have a foam texture created, which is just this color and this color and the noise map that we use as a mask here. You can just copy these settings actually. So we just have this texture plugged into the base color, and then the mask we created is going to the opacity, like that. Oh, the roughness is obviously 0 because water is not rough at all. As you can see, now you have foam. And at this point, I would say this is pretty much all what you need for the water. So if you're not interested how to create those little dots that is being, panned on the surface of the water that I showed you earlier, then you can just leave this as it is. It's perfectly fine. I think it's, for stylized purposes, it's really good. Or good enough for you to save yourself 2 or 3 days thinking and working on this, and you can now go ahead and customize it and make it pop. So this video is getting too long and the algorithm doesn't really like that, so let's just end this part 1 here and you can check out the part 2. So in this video we covered the basics of the single layer water material, which included the foam, the refraction, the normal maps. I think that's it. Oh, and the ripples. So in the next one, in part 2, you're going to learn how to create those little dots on the surface, and also the particle system for the bubbles, the post-processing volume underneath the water, and you will get every single one of the footage I made. See you in that one. Bye.